All right, ladies and gentlemen, today we're going to learn something new. We're going to learn about prime factorization. So remember that a prime factor is any number that is divisible by itself and 1. So like if you have 2, so 2 is only ever divisible by 2. So 2 divided by 2 equals 1. Or 2 divided by 1 equals, well, 2. Okay, so this is what a prime factor is. A prime factor is that any number that's only divisible by itself and 1. Okay, and there are a bunch of them. There's 2, 3, 5, 7, 11, 13, and they keep going until, well, forever, basically. So what we're going to do is we're going to learn how to take a regular number like this, and we're going to learn to break it down into its prime factors. And the way we do that is with this thing called a factor tree. So I'm going to show you, there are 2 examples, and then I'm going to show you, I'm going to kind of walk you through it one more time. So the way a factor tree works is it's like the roots of a tree. So if this is the tree right here, the roots go off in lots of different ways. One of the things you need to remember about a factor tree, though, is that it happens on levels. So this is the starting level. So this would be above the ground, and then there's the first level underground, and then the next level underground, and then the next level underground. And those levels are always equal to the original number. So this would be 3 times something equals 24, and this would be 3 times 8 is 24. Okay, now, every time you have a prime number, which 3 is a prime number, 8 is not, because 8 has factors. Every time you have a prime number, you just draw a line and drop it straight down onto the next level, because what's going to happen here is just like I did here. So 24 is 3 and 8, so or 3 times 8 equals 24. This one is going to be 3 times something equals 24. But this something times something is what times what equals 8. And for this, I'm going to put 4 and 2, because 4 times 2 equals 8. So now, on this level now, I have 3 times 4 times 2, and that still is 24. 3 times 4 is 12. 12 times 2 is 24. Now, oh, I did that wrong because of where their boxes are. So this has to be a 2, because the 2 is prime, and it just comes straight down. And the 4 is not prime, and it has to have its factors. So notice the 3 just came straight down again. That's because it's already a prime. Now 2 is already a prime as well. That's why there's a straight line, and that's why I did it wrong before, but now I know. So 2 comes straight down to 2. And then something times something equals 4, and that's 2 times 2. And now on this level, we now have all prime numbers. When we reach all prime numbers, the factor tree is done, and that's the prime numbers that make up 24. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So the prime factorization of 24 is, and we usually do it from least to greatest. So it would be 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. All right, so let's do another one here on number 1. And I'm just going to do this, and then I will do a couple over here just to kind of get you going. So they're giving me the 2's, a set of 2's here. So I have to think 2 times what equals 18, and that would be, or 16. 2 times 8 would equal 16. Okay, that's my next level. So notice there's levels here. The levels are very important to help keep you organized. You must think about these as levels. If you don't, it gets really wonky and you get lost. Okay, so the 2 comes straight down, so we're on this next level, and something times something equals 8. Now, this says that this is a prime number, and I know that 2 is a prime number. 2 times 4 is 8. I drop the 2 down because it's already prime, and then 2 times 2 is 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So there's 16. So the prime factorization of 16 from least to greatest is 2 times 2 times 2 times 2. Very simple. All right, so now I'm gonna show you on number 3 here with 18. And the reason why I want to show you with 18 is this. One of the things with a factor tree, the first level under the top Okay, and these little legs just show, they're basically just like pointers to show that this times this equals 18. It doesn't matter what numbers you put here as long as they equal the number above it. Okay, so for 18 we could have 2 and 9, we could have 3 and 6, we could have, that's about it. So we could have 2 and 9 or 3 or 6. It doesn't matter. They both will work. In fact, I'll show you both of them working. Okay, so here's 18. And let's say 2 times 9. 2 times 9 equal 18. Let's put it over here as well. Let's say 3 times 6 equals 18 because it does. Okay, so both of these can work, and I'm going to prove it to you. And look, I'm making my levels here. So this is my first level underneath. And then I'll have a level under that, and I may even have a level under that. I'm not sure. I'm just going to draw it there just to kind of give you guys a visual of the levels. All right, 2 is already a prime number, so I'm just going to drop it straight down to the next level. Now something times something equals 9, so I'm going to put a line here and a line here, and that would be 3 times 3. And 3 is a prime number as well. So here 3 is a prime number, so I'm going to bring it down, and then something times something equals 6, and that would be 2 times 3. Now, if I put these in order here from smallest to biggest, I have 2 times 3 times 3. Notice over here it's the same thing, 2 times 3 times 3. It doesn't matter what the first level under the original number is, as long as you get yourself to all primes, it'll be the same no matter where you started. So the prime factorization for this is 2 times 3 times 3. Okay, 63, 63, because it has a 3 here and a 6 here, that means it's divisible by 3, and it would be 21. So I'm just going to say that. I'm going to say 3 and 21 is my first level. So 3 times 21 is 63. That would be my first level, and then underneath that I keep going. So 3 drops down because it is a prime. 21 would be 3 times 7. 7, 14, 21. Yeah, 3 times 7. I drop my little lines here. I'm not drawing a line to the 2 and a 1. It's pretending like 21 is a whole number. It's just a line to the numbers below. So 3 times 3 would be 9, and 9 times 7 would be 63. So the prime factorization for 63 would be 3 times 3 times 7. All right, I'll do one more here with 40, and I'll do it multiple ways again, so you can kind of see that it doesn't matter what the next level looks like. So I could have 4 times 10 here, and I could have 5 times 8 here. Okay, started in 2 different places, gonna end up in the same place. So I'm gonna draw my lines here just to keep my layers correct. 4 is not a prime number. 4 is 2 and 2, and 10 is not a prime number. It is 2 and 5. Okay, 5 is a prime number, so I'll just drop it down. This would be 4 times 2. And I keep going here. 5 drops down. 4 is 2 times 2, and this 2 is prime, so we just bring it down. So you'll see now, I didn't need to go any farther here because these are all prime numbers. 2 is a prime and 5 is a prime. So my factors for this one is 2, 2, 2, and 5. Here it's 2, 2, 2, and 5. So the prime factors for 40 are 2 times 2 times 2 times 5. And that would be 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. That is how you do prime factor trees. Today you're going to do 2 through 9. You're going to go from here down to here. So you're going to finish the other 5 by yourself. Remember to keep your layers in order. These little lines that come off of non-prime factors to the level below are just lines that point to the factors that made up that one, which is this number, or like here, 3 and 7 make up 21. It's not 3 coming from 2 and 7 coming from 1. It's 3 and 7 come from 21. All right, there you go.